Salut coders, welcome back to another tutorial. Warm greetings to those who are joining us for the first time. In this tutorial, it's a completely free full tutorial for Spring introduction. I walk you through step by step of creating a Spring project, create RESTful APIs, custom exception handling, Swagger integration, MySql database connection. After the end of this tutorial, you are going to have a fully confident of using Spring Framework. You can build any reward application that you think of. So you are wondering why I choose Spring Framework, because it's fast, it's easy, and it's funny. Even to resolve errors with Spring Framework, it's easy as compared to other framework that I have used before. Spring Framework is a game changer. So let's get started.
What is a Spring framework? It is an open source application framework. It is used to develop Java applications. It was released in June 2003 by Rod Johnson. I love this framework because it is mature enough when I'm comparing with other Java frameworks out there. Why Spring framework? It improves code efficiency, reduces application development time, lot of support, and it is also an open source. It removes tedious configurations and focus on business logic. It is considered as a secure framework. How it works? It is divided into layers. We have view layer, business logic layer, and data access layer. These layers work together. The view layer communicates with the business layer, and the business layer communicates with the data access layer. So the user can give input through the view layer, and a business logic layer do its logic by communicating to the database through data access layer, saving the data or retrieving data. I will show you when we are doing the practical project. How it started? It started as an inversion of control, also known as dependency injection. The objects define their dependencies, and it is the other objects they work with. So we have an object depending on another object. So the inversion of control works on these objects by having those objects in a container. So let's talk about Spring modules. The Spring framework was divided into modules. We have a core modules, which is the base of the Spring framework. We are talking about dependency injection, internationalization, validation, aspect-oriented programming. We have also data access. We are talking about Java database connection, Java persistence API, and we are talking about also web. We are talking about Spring Web Flags, Servlet APIs, and we are talking also about integration module, where integration to enterprise Java through Java message services, remote method invocation. We are talking about testing module, unit and integration testing through mock objects, test fixtures, caching, and context management. What are you going to learn on this course? You shall learn how to create Spring applications, creating REST services, data persistence, saving data, retrieving data through the access layer, integration, Spring security with OAuth 2, Spring state machine, creating microservices using Spring Cloud, deploy our project on AWS, and many more. What are we waiting for? Let's get started in the next video by creating our first Spring Boot application. On your Google search, type start.spring.io. You will see this page. Now on project, select Maven. On Spring Boot, select version 3.06 for now. Then here on group ID, code with Bisky. Artifacts, Spring tutorial, then remove this package name. I want it to become code with Bisky. Packaging, select jar, and Java version for now select Java 17. So here that's where we add our dependencies. I will show you this dependency POM file. So for now, let's add few dependencies: web and Lombok. Add these two dependencies for now. Then click generate. Yeah. Then go to your downloaded folder. For me, I show in Finder, and I will unzip this folder. Then open with your IDE. For me, I use IntelliJ, so you can download your IDE. So if you want to download your IDE, if you want to use IntelliJ, you just come here, and for me, I use JetBrains toolbox. I'll select this toolbox, and you can download your toolbox based on the operating system. After you're done with that, you can install. Once you install, you accept the terms and conditions. Then after you're done, on right corner, if it's Windows bottom corner, you see this box like this. This is your toolbox. So on this toolbox, you select. That's where you select your ID that you want to download. You just search it. For me, I currently installed IntelliJ, so you can download your IntelliJ. You can search like IntelliJ, then you can install. That's all. Then you open it. For the first time after you open it, it will be like this. So you just click open, navigate to your download folder, go to your downloads, select the unzipped folder, the unzipped folder, then select the POM XML, then open it as a project. After you open it, it will download all dependencies. It can take time to download the Spring Boot dependencies for the first time. So for me, the dependencies are now in my local computer in the a.m2 folder. So once you are done, this is your first project, a Spring Boot project. Let's go through this structure. So here in source folder, main Java, this is the package name. If you come back here, you see this is the package name, com code with Bisky. This is the same as this one, com code with Bisky. That's where you write your Java code here. So in resources, that's where you put all your resources folders. We have application properties. For me, I don't use application properties. I usually refactor this one and use it as application.what.yaml. I use it as a YAML. It's the same, but the structure of YAML is better as compared to properties. Then here in test, that's where you write your unit test, integration tests. So we will do that. We shall have a tutorial for unit tests after we are done with these tutorials for Spring starters. Then we have this POM XML file. What is a POM XML file? So this POM XML file, we have a list of dependencies here. The root folder is project, and each project has an group ID, artifact ID, version. These are the common. From here, this is the group ID that I typed here. This is the group ID that I typed here. The artifact Spring tutorial. This is the artifact, and this is the version. By default, when you generate, it will be 0.1 snapshot. And I'm using Java version 17, and also the artifact. These are now the dependencies. So it's an array of dependencies. So we shall add more dependencies here that we want to use on our project. For now, we added the Lombok one, this one in the web, and this is the web, you see, and there's this one, starter test, which was added automatically by the Spring when it generated this folder. So don't worry about these ones. For now, just know that so far we have these two dependencies that you are going to use, and we are using Java 17. So let's try to run our application. Just click this run, click run. You can see our application is now running at port 88. So here, since I added Lombok, it allows me to enable the annotation processors. So just enable it. It's now running on port 88. So far, there's nothing is there for now. We start to create endpoints and consume our REST services. So I will stop the project. So how do I change this port? Maybe for you, maybe there's a service that is currently running on port 88. So if you want to change a port, you just come here and type server :port. Then you can say any port 8990. I know there's nothing that is running on that port, so you can run it again, and you can see it's now running at port 8990. This is how to change the port. The configurations are very, very easy as compared to other frameworks. So like this, you change your port of your project. So this port, they are like each application is its own port. For MySql, it uses a port 3 I can't remember, right? A Postgres has its own port. Your application must also have different applications. So make sure you have your own port, which is different from other ports. Then what else again? For now, this is an introduction video, just going through the structure of this project, and this is your application, Spring Boot application, and we have the main class. In Java we have the main class. So when you run your project, you are running this one. About Spring Boot application, don't worry about this for now. This annotation is required for you to run a Spring Boot application. Without this application, you won't run your project. So we shall go through bit by bit on this project. And what else again do you have to know? So after installation, maybe you have a challenges of Java, or you don't have a Java in your computer. So what you do, you have to come here, click File Project Structure, go to File Project Structure. Usually you have to come to SDKs. You click the SDKs. You can click this plus button, then download JDK. This dialog will pop up. Then you select Java 17. So for me currently, I installed Java 17. I didn't install this Java, so you just select the Java that you want. So if you want this, you just download it. Let's wait for it to download. So I'm now downloading Java 20, but for you are supposed to download Java 17, because the project is for Java 17, and here we selected Java 17. So after download, you then come back here. You see the name of your project. Then on SDKs, you select the Java 17, then you click apply and OK. After that, everything's now sorted. You just run your application. It will sync here. After that, you can see these green buttons. Just run it. We are going to talk about building REST service with Spring Boot. REST has become a standard for building web services. They are easy to build and easy to consume. This tutorial, we are focusing on building RESTful services. Its text includes, it has different actions, get, post, put, and delete. Security, encryption and authentication, redirection and forwarding. Another one is caching. Our first annotation is a REST controller. We will create a user controller.java. We will add an annotation at REST controller to mark the class as request handler. A request handler is used to process HTTP requests. A request at REST controller is in web dependencies. We added this dependency on our previous video. If you haven't watched it, go and check our previous video. So as you can see on the screenshot, this is a class at user controller. Then we annotated at REST controller to mark it as REST request handler. Another annotation is at get mapping. So all our methods here, we are going to add at mapping, either at get mapping, at post mapping, at put mapping, at delete mapping. So at get mapping is when we want to get a resource from the database. So we have our method get user ID with a path variable ID. So this ID is matching with the ID in parameter of a get mapping. So they must match. At post mapping, we use this annotation when we want to create a new resource. So on our method, we annotate our method with a post mapping, and in the method we add a request body with another annotation at request body. It's either our user class. For here, I just added object class so that you know that we need a class here. And we have a put mapping. We use a put mapping when we want to update a record on our system. So here we have a path variable which we are going to use to identify the record. We first fetch the record if it exists. If it's there, we can now update our object with the object that we pass on at request body. It is simple. I will show you on the next lecture how to do this. And at delete mapping, we want to delete a resource on our system, so we can pass an ID which we know that this record exists on our system, so we can delete it. So we use ID as a unique identifier to be able to delete a user on our system. Another thing that we must talk about is response entity. It represents the word HTTP response. It has header, status code, and a body. So we shall use a response entity to provide a response body, a JSON response body. So I will show you how the JSON looks like, and each response must have a status. It's either okay, in error, is it created, is it security issue. So I will show you how to do this. A list of response code is that you must know as a beginner. We have a 200 for OK. We use it when we want to get something from the system. We have 2001. We use it when we updated or created a resource, or we create our user or update our user. We have 400. Let's say when creating a user, a field username is required. So when creating it, it was missing. So we can return with a 400 and error telling the user that this field is required. We have 401 and 403. These are used on security. 401, we are trying to access a secure endpoint, and you don't have any token on your headers. So we throw an exception 401, or your token is expired, so you can refresh another one. 403, you are authenticated, but you don't have permission to access that resources. You don't have the role, so you can return it 403. And 404, we are trying to access a user which does not exist on our system, so we can return it 404. 500, an exception was thrown on our system, so you can return 500 as an internal server. 503, your service is down and it's not running, so a 503 can be shown as a service unavailable. Later on, I will show you how to do this to have a high availability application so that you avoid 503. So what is a JSON? A JSON is a JavaScript object notation. It is a lightweight data interchange format that is easy for humans to read and write, and easy for machines to parse and generate. It is a way to represent data in a structured way using key value pairs. As an example below, you can see this is a JSON object. A JSON object starts with curly brace and ends with curly brace with a key value pairs. We have an ID, which is the one that you are seeing, a UUID, a name, it's Bisky, last name Musweet, username Bisky, email contact@bisky@gmail.com, and you have age, which is 30, rows developer, maintain, admin. On rows, it's a JSON array. So inside a JSON object, you can have another JSON object also, or you can have a JSON array. Later on, I will show you. So on our RESTful services, we are going to consume a JSON object and produces a JSON object. So this one is a user object. So what's next? We are going to create a user controller.java class in the next lecture, and we are going to create also a model user, and we can start to add all the annotation that I showed you at get mapping, at post mapping, at put mapping, at delete mapping. From the previous videos, I showed you the theory, how to create a user controller. So in this video, I'll show you how to create a user controller and create a user model. So from the previous project that we created on our second video, we are continuing from that project. So click source, main, Java, and our package is com.code with Bisky. So here, create a new package, name it model. Let's create a class called user. Then let's add few fields here. A user is a private string ID. This is our unique ID. Then username, first name, last name, age, and the age is an integer. Private list of string, import the list. These are our rows. So we have to create getters and setters. So right click in your class, generate getters and setters. But for me, this is I don't like this. This is dirty. This is dirty. Let me show you the other way. When we created this project, we added a Lombok dependency. So the purpose of that dependency is this I'm showing you right now. So you annotate this class with getter and also annotate with setter. So it is the same like creating getters and setters. So now this is now smart and easy to read. So after doing this, let's create our user controller. Let me copy this, create a new package again, which is controller. Then a new Java class, user controller. So all our requests to go through this user controller or users. So as we spoke on the previous video, we add an annotation address controller and add this annotation at requests mapping, and here put add users. So all our requests to start with users. I will show you using Postman. Then we are now creating our methods. Our first method is to get a user. So I told you on the previous tutorial, when you want to get a user or you want to get something, you use add get mapping. So let's do that. Add get mapping. All these annotations are coming from the web dependencies. So public response entity. We talked about this response entity, whereby our response we have a header, a body, and a status code. So we want to return a user. Let's import our user. So get user by what? By ID. So if you want to get user by ID, we know that here we are supposed to pass a string. Our ID is a string, but for this your ID to be recognized via a REST controller, we have to add a path variable, and now we are having this error telling you ID is never used and cannot resolve ID in the request mapping. So here in our request mapping, get mapping, we are going to do this. You can see. So we are now able to pass /users/id, and the ID will be any like 1 or 2 or 3. So for now, let's put return now. So you want to return a user. So how do we return a user? We return it with our response entity. So here you can just say response entity dot OK, and for body, for now let's put now. Let me create a sample user, private simple user, just for testing object, get demo user. I'm doing this because for now we are not persisting our data from database. Later on our later videos we shall create persisting this data and retrieving it from the database. But this just for testing. Let's create this user. So here we want to return a user. So the user, let's create a new user. Goes to new user dot set id one, set first name Bisky, set last name set age. This is an integer. Set rows, arrays dot is list. Our first row will be developer maintainer and admin. Then we'll return this user. Then from here we just add this. So it will return an OK. An OK is a response body. You can see OK is a status OK, which is a 200. So when creating, as I told you, you created, you return 201. These are the list of responses, and I told you about 400, which is a bad request. The request that you are posting is bad, and 401 unauthorized, 403 they are forbidden to access data endpoint, 404 not find, the resource does not exist. And these are the list of response code that you can use. 500 internal server, 503 service unavailable. So for now we can do this, and so this is the way, this is our get. But I don't like this way of creating this like this. So let me show you the Lombok way, in the smart way. So here you go to your user class and we add an annotation at builder. Then you come back here. So here is now a builder. So we can do this user dot builder dot id will be 1, like what we did before. I'm just copying that this one is the smartest way. Dot first name, just copy the first name. Here, this is the last name. Last name, age will be 30, and check our rows. After that, you just say dot build. That's all. Then you can remove this code. As you can see, it's now clean. You are no longer a beginner now. This is a smart code, easy to read. So this endpoint, the get mapping, we want to get this object. So we are returning this response, and it will be a format of our format of JSON. So it will produce a JSON. So here you can just specify that it produces, and then you can say this produces. We can see the produces. Where's produces? In array. Then it's a media type dot JSON application JSON value. So our response will be a JSON. If it's XML, you just say application XML value. So that's all from here. So let's test this endpoint. I think this is if that is currently running on this. So this one of 8990. So this port is being used. Don't be surprised when you see this. It means the port is already in use with another service. So for now, let me go into application YAML and update this to 91, and we can run it on port 8991. Yeah. So users ID, then you can pass anything for now, and you return our user. Let's test this with customer. So here, so the end you type localhost because it's running on our local computer, // 8991. The endpoint that we want to access its users. As you can see here, we want to access users. Since it's a users controller, if it's another controller, you can just differentiate them here. So everything that you access in this class, all of them, they're in users path. So that's why our controller is what? A user. Is a user's path, and our ID, this is our ID, this is the path variable. If with this / and an ID in those parameters, it means it's an we are accessing this is a path variable. All path variable has these curly braces, so don't be surprised if you see this one. So if it's a string, it automatically convert to a string. If it's a long, it will automatically change it to a long. It depends, but for me, all my IDs will be strings. So now let's test the endpoint. Let's send. The problem that 405 method not allowed, because here I selected a delete, of which on our service we have what? We have a get mapping. So far we don't have a delete mapping. So we didn't reach our what? Our endpoint, a get mapping. So let's update. It's another response code 405. So let's change it to get and send a request. You can see this is our response code and it is a JSON. You can see here JSON and our response code is 200 and it took 38 milliseconds to get a response, and this is the size 283 bytes. So our get mapping is working correctly. So let me show you how to create. It's easy. Now let's copy as it is, and this is going to be a delete. So delete user by ID. Let's change the method name. Delete user by ID. So if you try to run this thing, it won't work because it's now we have the same get mapping with the same path variable. So we are supposed to have a unique endpoint for each request handlers. So here let me change it to delete mapping. Now delete mapping. Then for a delete, we don't want to return anything. So the other way you can do that is response entity response entity status. We just say okay. HTTP status okay build without anybody. So we will not get anything. It will return an empty response body. Let's test this. So let's go to our postman. In our postman, you can see this is the get, and if you hit a get, but remember last time when you did a delete, what happened? It returned 405, but now we have the endpoint. Let's see what happened. You see now, because we added a delete, we are now getting a response 200. Okay, no, we are no longer seeing that error 405 because we implemented that method. So let me show you how to create a resource. Let's create a new resource. So creating a resource, I told you we use a post mapping, then public response entity. We want to return a user, create a user. This is the endpoint to create a user, and we use a request body. Then our object will be user. This is the JSON or the JSON object that we are going to send. So for now, we are going to return the object that we passed here. It created, I told you when you are creating a resource, you can return a 201. Usually, most developers return a 200, but for me, I want to do things the right way. 201. So body will return the same user that we passed here, and it will return a response code what 201. Means we created something, so it means we saved something on our DB. So let me run this. So let's go to our postman. We are now use our postman for our testing, all of our testing. So here, copy this endpoint, create here, paste this, change here to post. So right now our post does not have, our post mapping does not have this path variable. So we can remove this one and go to body, then select row and change here to JSON. So I want to copy an existing JSON that we have. Okay, forget. Let me copy it. So in creating, we want to create. So for this one is for, you can remove the ID when creating. So we don't have an ID. Username, let's say test. First name, test again. Last name, user, age 24, roles developer, admin, yeah. And also just say if this role employee does not have this one, if this user is not a maintainer, yeah. Then after doing this, you just click post. You can see the same request that we sent, we get the response, we will get the same response. So as you can see, the status code is 201. So the endpoint has reached our endpoint. The request has reached our endpoint, and we get 201 as a response code. And this is our body, and this is the list of headers. Since I told you the response entity has headers, body, and response code. So that's all for posting for now. And the post mapping and the put mapping, they are just like the same, but when you say it put mapping, we are updating. So this is the basic CRUD: create, read, update, and delete. So here we can say put mapping. So here we are now updating user, update user. So here we want our path variable, which is in. So what you do, we pass an ID on our endpoint. Then what you do is to first fetch the record. Once you get the record, we then update it with the details that we pass here. So how, like what you did on get mapping, we have to come here, just copy as it is, right, and paste here. This is an ID. So here you can, if you type user ID here, it will say user ID variable, user ID, like cannot resolve user ID in request mapping. So you can, what you can also do here is on path variable, you can just say ID. So this ID will match it with this one. But if you don't want to do this, the path variables and on put mapping, and this must match. So the error is gone. This is matching with this. So this is the put mapping. For the put mapping, you are updating the record that already exists. So the logic here is to first find the record by ID, So let me do this. If it is exists within update the record. Here we can do also another validation just to check if user name exists. Throw an exception that the user already user. Here just the same. First find the record by ID if it exists, then delete the record. This is the delete mapping. Here we are now finding the user by ID. So for put mapping, last example for put mapping is just the same. Let's run this application again, and here our method type we just change here to what? To put mapping. So for put, I told you for a path variable you must pass an ID. Let's try to do it without this one and see. You see, method not allowed 405. So our put mapping here is expecting what? An ID what? An ID that is already exists. Then you do this and then it will return our object. So this is the JSON object and this is the JSON body. So we are sending this JSON body to our request to our endpoint, the put mapping, and this object will be converted to a user class with the annotation it requests body. It does implementation to convert it to a class. Then you are now able to consume to use it as to consume that as JSON and able to use that class, and then the response entity will then convert it as a response as JSON response. So today I want to tell you about a request parameter and a request header. So before I continue, I refactored some bit of this code. I added get users. It's now a list of users. So here I created 4 users. So we are adding each user with a different ID, different username, and their names, last names, and age. So on this demo user object that we are calling here, we have the ID, username, name, and last name. This name is the first name. Let me refactor it. Just a first name. So we are going to delete this one that we were using on the previous video. Okay, This is we are doing some refactoring and get users. So here we are now having an exception because we deleted this method that does not have any parameters. So what you want to do is to get from this list. So it's going to be a list. So it's a list of users. Stream dot. We want to filter our user with an ID user dot get ID equals to the ID that we passed. The ID must be the same. Find first or else return now. If the ID does not exist on the list, we will return now. So here we are expecting to get a user. So if we send on our parameter send ID1, we will return this object. If the ID is 3, we will return this. So we are now removing the hard coding, that we did for that we're returning. So here if user 1 is now, if it's now as I told you on the previous tutorial, it means the resource does not exist. So we return 404. So response emptied status not found. Like this, else we return our user. That's all from here, and it's the same. So it's the same here. We can just copy here. We can just copy here. Not found, else, then logic to delete. So that's all for this. So here I want to tell you about a request parameter. A request parameter is when we want to fetch based on query parameters or form parameters. For here I want to give you a simple example. So we want to search users from our list with the name John. So we have this John and this John. So we are going to fetch by first name and we get these two records. So let's implement that. So for here I just want to copy to speed up the process. I just want to copy get one because we want to get the list. So here we can say get users. It's now users because it's now a list. Get users by first name. So yeah, I can say the name of the endpoint is search by, I can say search by first name, and it's supposed to return what? A list. Here is now what? A request parameter. It's now a request parameter. We want to search what? I can call it name or first name. Okay, so here we can now filter this. It's the same as what we did. So it will be filter user get first name equals, ignore case, it's either small letters, first name, then it's going to be a list. If you type .var at the end and press enter, you get the it will create for you the variable, the variable. So here we will return a list of, it will return a list of users with this first name. So let's test this. So here it will be users search by first name and the parameter will be first name. So let's test this with Postman. So it's local host. I think it's running on port 991. Users search by first name. You put here. It means now we are adding our query parameters. So the name of the parameter is what? First name. And we want to search John. And then we click this. You see, on our response we got two results, John White and John Snow. This is working as expected. And the query parameters, you can see here, these query parameters in Spring we just add this annotation at request parameter. That's all. Then let's test the other endpoint that we modified. The get by ID, it's running on port 91. So this, we don't have this user ID 24. If we send a request we get 404. But let's test with the ID2 and check. You see the ID2 is John White, and the ID3 it's what? It's Paul Walker. So here we are sorted. As you can see, ID2 is John White, ID3 is Paul Walker. So for this now I want to show you another annotation. We call it @RequestHeader. What we can have our custom headers. So we can say X API key, then we say string API key. So this is just put outer and then it custom header. So what happens with this when you see you're sending a request to this endpoint, it means it requires a custom header, an X API key. If it doesn't exist, you get a 400. As I told you, it means the request that you're sending is invalid. So let's test this. We already have this endpoint search by first name. So let's go to our postman. And from our postman here, I'm sending a request now. You see, we are getting a 400 bad request. This is the response code. Why did we get this bad request? If you come here, it is saying required request header X API key for method. So you just come here and you go to headers and add this header X API key, and this is our API key. Then we send. Boom. So that's all for this. You see, we retrieve our response because the request is now correct. Today we are now moving on business layer, whereby we use the annotation at service. This annotation is also the same as at component, but this one is now specific. We are telling that this class is at service and it will be added into application context with the Spring, and Spring will fully manage this class. So we are now moving our logic, which is in controller, in user controller. This logic, this business logic, we are moving it to the service so that the controller become clear, and also all the business logic dirty code you put it in a service. So let's get started. Let's create a new package. We call it what? Service. So in service, let's create another package. Also call it user. In this one, you want to create an interface first, a user. Let's create as an interface. So let's add our first method, user get user by ID. You see, our ID is a string. Then let's add another one, void delete user ID. Then create user and we pass our user. This one is going to be update. Then instead of user, find users by first name. So our save is done. Let's create the implementation. So this is the standard way. of creating a service, we must create an interface and then its implementation. So here we want to copy all the logic from the controller and put it here. So you already have this. So what should we do first? Let's copy these two methods. Let's cut them, put them in our business logic, which is our service. Go back here. We already have this one. Let's cut it and go here. Go to our method find user by ID, and then let's do this, and it will return this. Then we can go here again in our controller. So we are going to replace this battery. I'll show you how to do it. Then we can come here. This is a user update, and also here you can cut this also. And this is the logic. Put in inline. For update, just for now, let's do this. For create, let's return the object that we created, that we passed as a variable. On the later video, I will show you how to persist the data into the database and get a user with an ID created from the DB. And this is the void. So here, on this one, we know this is our business logic. So let's annotate with what? With its service. So by doing this, Spring will manage this logic. It knows that this is a business a business logic, and will be added into application context. So the inversion of control is now working. So you can see after doing this, you can see this icon that says, you can see it means it's now added into the inversion of control. So let's copy the user service, and come here into our controller. In our controller, let's do the dependency injection. Let's reuse that service. So by doing this, we can create a constructor. So you can see this one, auto wired dependencies. It's now dependency injection is working correctly, and you can see this arrow. Let's try to remove the annotation. You can see the error. If we remove this and come here, you can see an error could not auto wire, no beans of user service type found. It means the bean is not in our container. So if you see this error, you can go to the implementation part and add service, and the error is fixed. So you can navigate to where it is auto wired here. So now let's use this one. So here it's get user by ID. So service dot get user by ID. Then you can pass the ID. So this commenting part, we can move it to this commenting part, we can move it here. For this one is delete, what's that? Delete user by ID. So this logic, we can put it in our implementation, delete user by ID. Here, since we know that we have the ID method, we just do this. We pass the ID. If it's null, we can throw an exception. So I will show you later. We can create our custom exceptions. User with ID ... not found. Okay, let me do this. User with ID %s. Throw an exception, then you do the logic to delete. So here now controller, in the delete you just say user service dot delete, then you delete by ID. For create here, you just say user service dot create user. So it will return what? A user. User service dot create user, like this. User service dot update user, the ID and user. Then here user service dot get find user by first name. Yeah, you can see now it's not clear. The code is not clean. So that's it. This is what we aim when developing backend. Your code must be clean and easy to read. So I'm showing you the best way to write clean code. Now it's running, it's okay. Now it's okay, you can see the code is now clean. So let's test. It's running at port 991 and you can send a request, you can see. So that's all. On this tutorial I showed you how to create a service with interface and implementing that service, Then you add an annotation at service to mark this class as a service component, and Spring will add it into application context, and Spring will manage this class for you, and you auto-wire this service. This is the constructor dependence injection, and there's also the other way, but not the recommended way, whereby you can, this is the recommended way of using constructor. There's also the other way of just adding this annotation. It auto-wired, sorry. And if you move your mouse to this, it tells you field injection is not recommended. So the recommended way is to use the constructor. So get used to use the constructor. Thank you guys for having fun on this video. I think you learned a lot. The business layer is almost done, so we'll come with another video showing the other things, and I want you to know a bit more of these annotations so we'll be familiarized with Spring Framework. They are easy, but you have to follow these tutorials from the first video so that you can understand each and every annotation that you are seeing on this video. On this video, I showed you how to use a service at auto-wired, and also it will work also on the implementation to remove a service and add a component. A component is just an abstract, but it will work. But if you doing the right way, if it's the business layer, let's use a service. Last time we spoke about business logic layer. Today we are talking about data access layer. This is our first tutorial about data access layer. Today I will show you how to connect to the database. So let's get started. So there are two dependencies that you are supposed to add. I showed you how to add a dependency on the first tutorial, and in this tutorial we can go to form file, then we add two dependencies here. So we add MySql dependence and a Spring Data JPA dependence. So add this dependence in your POM file. These dependencies, we will use it to connect to MySql database, and we will use JPA to persist our data. I will show you on the next lecture when we are starting to persist our user into our database. So for now, just add these two dependencies. After you added these dependencies, if you try to run you can click this Muffin first to sync your dependencies, or go here and click this refresh button, then it will download the dependencies. Then let's try to run. If you try to run this one, we'll start to get an error of data source. As you can see, failed to configure data source URL attribute. So we have to add this. Also here we can configure this URL in our application YAML in this file. You can add this configuration as with a Java class or the YAML file. So on this tutorial, I'm going to teach you how to connect to the database through adding it to your YAML file. So what do we need? Which configurations do we need to connect to the database? So the configurations, we must add in MySql and JPA. So we have the Spring data source, where we have our class name, driver class name, and we have a URL. The URL to connect to the database is either your local database or a remote database, which is on MySql, a cloud database, and a database, a username and password. So let me share with you these configs. So these are the details that you need to connect to the database. So the data, this is the data source, and we have, as you can see, it failed to run because of the data source. So this one, it was searching for this attribute, which is Spring data source. In data source, we have driver class name, which is MySql driver. If it's a Postgres driver, you add the class name for the Postgres, and we have a URL which you connect to the database. So we start with JDBC, then MySql. Here we put the URL. So my database is running on my local, and port 3306. Create database if it's not exist, and this one is the name of the database, the demo. So I can say it Spring tutorial. This is the name of the database. So if it does not exist, it will create it. Then other things these are just parameters. Don't worry about them. Just add. These are the basic, and these are the important ones. So you can connect to an existing database or create it if it does not exist. Then this is my username and this is my password. So for JPA, we want Spring to create tables based on the classes. So with the different strategies. So for JPA, we can add also JPA configurations in same line with data source. Spring, you can see Spring data source, Spring JPA, generate DDL. This is allows us to create DDLs and show SQL queries when we are pulling data using JPA. We'll be able to see the queries that are being invoked by Spring, and type of database is MySql. If it's Postgres, you can add Postgres. Then Hibernate. For Hibernate with this DDL auto update. So if the table is already there, it will update. If you add new fields, it will update with the new fields. Then naming strategy, keep it to improved naming strategy, and the dialect that you are going to use, it's MySql 5.7 dialect. So these are the configs that you need to connect to the database. Let's test now if we are able to connect to the database. We are not supposed to see any error. No, our application started successfully, no error now. Let's try to put a wrong password and see if the configs are working correctly. Let's run the application again. Yeah, you can see there's an error. It failed to connect to the database. So our application is working correctly. These are the configs that you need to connect to the database. Thank you guys for watching this YouTube tutorial. Now you are able to connect to MySql database with Spring Boot. It's easy. Only these configurations that you have to add, and also these two dependencies. Today we are going to persist a user into our database. I will show you how to do this. So let's get started. So on the previous video, we managed to connect to the database. In this video, I'll show you how to persist a user. So let's go into our modules, to our user module. There are a few things that you want to add. We added a JPA dependence on the previous video. So let's use this one to persist our user and to add some constraints to the user class, and our entity will be user. So we know that when creating a user, we must have an ID. So what you do here, we must add it ID. We must add it ID, and we want to create a auto creation of a ID. When you save, we get unique IDs generated automatically. So we add it generated value. So for this, I want to use a generator. I want to use UUID, and I want to use the class, the generating class strategy. I want to use UUID generator from Hibernate. So you can add this annotation at generic generator, at generic generator from annotations, and the name will be the same UUID, and then the strategy is coming from this class org.hibernate.id.uuid generator. Then, and for our username, it must be unique always. So you add column unique. You set it to true. By default, it is false. It must not be nullable. False. And also for first name, we want to have for first name, add column nullable false, and also last name. Then the other thing for this class, so to be able to persist this class, we must add an annotation which maps our fields to a relational table. So we add this to differentiate this class from others. We make it at what we must add this at entity for persistence. Yeah. So now it's because I added this at builder. So that's why. So to fix this error, if you want to use at builder, you just add at args constructor and add no arguments constructor, and this error will be fixed. But for this one, if you move it will tell you that the attribute should not be a container. So to fix this one, let's for this list of string, a separate table will be created with a list of rows with map user to a row. So you just add at element collection. So that's all from here. So here we are able to create a table with a list of these fields, and a unique ID will be created for each user, and username must be always unique so that one username per person, and the field must not be empty, and also this one must not be empty, and first name and last name. So how do we save now this user? In Spring, there's what they call a repository. It's an interface which is provided by Spring. So we have CRUD repository, pagination repository, JPA repository. So here we want to extend JPA repository. So let's create now our package, call it repository. So in this, we want to create a user repository. So it's an interface. So it's user repository. This repository we are going to use it to save this user entity and to retrieve data, to get number of users that are in the database. So we are the Spring has provided us a methods to use. So here we have to extend JpaRepository. So the first argument, we will say we want to use a user class, and the second argument is going to be your ID. If your ID is string, you put string here. If it's long, you put long here. So for us, our ID is string. That here, this is a string. That's why we put string here. And here it's user. Here we need a class that a class that needed here is with entity annotation. So after we are done with this, we just go here and copy this one. So in this JPA entity, there are so many methods that are here. We have save and flash to save our user. It's a generic method, and to get user, to delete, find all users. It's a generic. It depends on the class that you passed here, and it also extends list CRUD repository, list page nature sorting repository, query example executor. So if you go into here, we end up in CRUD repository where we get findById to count the number of items, to delete. So you can also use these methods also. So here let's go into our interface on our implementation. So what you have to do is to say private final user repository, then we want to use this. So as I told you, in terms of dependency injection, you can generate a constructor like this one. So by doing this, we did dependency injection, so there will be no null pointer exception when using this, right? So to save a user, you just come here in this create user, you just say user repository dot save in the name of our entity here. So by doing this, we are now able to save our user. Let's run this application. So let's test. We want to be able to create a user. So on our user, the username here will be Bisky. First name Bisky, and the last name it's Musweed. Age 24. Let's leave it as that. Then we are calling this our domain. We are on localhost running on port 8991, which is this one. Where's the port? Where's our port here? This port, Tomcat started at port 8991. So you are seeing here, when we run the application for the first time, you see we're able to create a table called user, and also user rows, and an index was added, and a unique constraint for username, and a foreign key user ID on this table user rows. So it's because of this generate DLL is true, and we are seeing these logs because we enable show SQL here true. So, and we told that create database if not exists, so our database was created. So let's test this one. You see the ID, we are able to test this one. You can see
a new ID was created here. This is the ID. You can see on our request it didn't send an ID, but we get an ID on the response, so we are able to save our user. We can test this by looking into our relational database. Here I'm using data grip to test this. So let's refresh and look to the name of the database, Spring Tutorial Database. So what you can do here, this is the name of the database. Let's refresh here. This is the database name. When we do this, this is the database name. And it has two tables, user and with the ID, this one which was created, you can see it on the postman, the same ID, so we are able to save our user with the first name, last name and username. And this user is a raw employee. So you can see now we are able to create our user with Spring Boot. Then let's test the get. So here if we try to get this one, here we are using, it's because we are okay, right now we are not able to test the get because we are using a demo. We are using on the implementation, we are not pulling it from the database. We can do the get in the next episode. Thank you guys for watching this video of creating a user. I showed you how to create a user, how to create a repository, and also testing with Postman how to create a user and a new ID was generated. Let's meet on the next video where we try to get this user from the database. In this tutorial, I'm going to show you how to find a user by ID. On previous tutorial, I showed you how to save a new user, so I will show you how to get that user by ID. Let's get started. So on previous tutorial, I showed you how to create user repository, and with the user class, and this string will be the ID. So we know that our ID is always a string. So let's go into user service implementation, where we implement how to find user by ID. So we are going to use this user repository. So on the previous tutorials, we were looping get users just for testing. We were finding based on the ID that we had coded, but now let's find by ID from the database. So here it's simple. You just type repository, user repository dot. We have this method in our repository, find by ID. So and then you pass our ID, and this method is an optional. So if the ID does not exist, we want to return now. So or else return now. That's all. Then let's delete this and run our application. So let's test with Postman. Previous we were using 1, but let's test now. Since 1 does not exist in our database, I send a request and we get a 404 here. So let's look for the ID that we already saved. So in our system we have this ID which already saved on the previous tutorial with the first name Bisky and last name Sweet. So we just copy the ID and come here and replace 1 with this new ID and then click send. So we successfully get our user. You can see it's status code 200 and username is Bisky, first name Bisky and last name Sweet. So while on the previous request we get 404, we can see In our controller, we are checking that if the user does not exist, if it's now, it means it doesn't exist, we throw a 404. That's why you get a 404. It means we don't have that resource. Today I will show you how to delete a user from the database using the delete method from Spring JPA method. So let's get started. On the previous tutorial, I showed you how to get a user by ID. We added a logic to do that. So in delete method, we want to delete that user by ID. So here we create a method. We call our method getUserById. When the ID is null, it means we were trying to delete something that does not exist. So we throw an exception. So for now, I'm showing you how to throw a runtime exception. It will return a 500 error. Later on the future videos, I will show you how to have custom exceptions and have a proper response with the proper response message. Then here below, we now add the logic to delete. So here you just say user repository dot delete. Then we will delete our user one. It means the user exists. So by doing this, we are now able to delete our user from the database. Let's test our code. Then we can run it. It's running on port 991, and let's open. Then here we want to test. This is the user that we used on the previous video to get. So let's try to call this user. Yeah. So to delete, we take this user ID, and we want to delete this record, and it also has a raw employee. So here, this is the ID that we replace here. Then on this method, you choose delete, and it is running on port 8991. So let's call this method and see. We get a response code 200. It means the user was deleted. Let's try to send it again. You see, an error is now showing here. It's because we already deleted the user. And you can see user ID, this one does not exist because we deleted it. In this tutorial, I'm going to show you how to update a user. Let's get started. So we are going to update the first name, last name, and age of our user. So we are going to create a TTO package. Let's create it. I'll call this package TTO. So in this TTO, the order was to create a TTO, say user DTO, and we add the first name, last name, and the age properties. But with this new way to remove the boilerplate code, we are now creating a record. So let's create a user update record. New Java class, call it user update record. We want to use a records. So here we remove the class and type record, and then here we put string first name string last name int age, and we can also return our ID string ID. That's all. So with this, it's now a clean code. So we want to send a request to the postman with these fields: first name, last name, and age.
and the response will be also user update record with the updated ID. So let's come to our service. We want to change here on our update method. Previously we're returning a user, but from now on we want to return a user update record, and we want to send a user like this. There are two problems here. Let's go to the first one, to the implementation. Here we can change it to this, and we can import then our method will return a user. Then let's go to the controller now, where we are calling our endpoint. From our controller it will be like this. It's now returning a user update record, and here in the request body we are sending a user update record and refactor here. Let's rename it to user update record. That's all now. So let's do our implementation. So the first thing is to find the user by ID if the user exists, so that we make sure we're updating the correct user. And this is our user. Let's rename this to user update record and change here. So previously we did this. Let's just copy what we did previously. If user does not exist, we throw an exception. Then now it means the user exists. So let's update with these new fields. So user.set first name, then from user update get first name, set last name. Here we are getting from last name, set age, and we are getting age from our record like this. It's set age, it's an integer. So we want to return this class with an ID now. So what we do is to create an object. Then here, so before we do this, we set the new values for the user. So let's update this. Let's update this user. We just call user repository, save, then we save our user with the new details. Then we want to use these saved details to make our new user data record. Get first name, last name, age, and ID. So what we do for a clean code, let's do this. Here we are getting exception because it's expecting a user update record. So just pass this thing like this. Make it in line. That's all. So let's test our code. Here, let's click here. Let's run our code. And then let's test it. So if you click the get endpoint, On the previous video, we deleted this record. If you click this one, we'll get 40. Let's create a new user on this port 1991. You can see a new user was created, and we want to update this user with, so we can copy this user here and test with our get and see which information are we getting from the database. And then click here. You see this is the user that we saved. So let's test to update this user for the first name and last name and age. So in our update, first name I'll call it 123 Bisky 123 and last name Sud 123 and age I update to 32. Then on our URL it's localhost 8991 users and the ID that we are passing, the ID of the user that you want to update. So let's test this one. You can see our user has been updated. Let's test also with the get method and see if we are getting Bisky 123 and Sud 123. You can see our update is now working correctly. In this tutorial, I'm going to show you how we can create our custom exception and handle them globally. So you call it global exception. So let's get started. So let's create our first custom exception, not found exception. Why did I choose this exception? Because on previous tutorial we're just throwing runtime exception, so when the user does not exist. So I'm thinking to create a not found exception. So let's create a new package and call it exception, and we can create a new class called not found exception. In this class we extend runtime exception, and I want it to have a message. Okay, let's add an annotation, a response status here, which is HTTP status not found. So add this annotation, add response status. HTTP and here just add a constructor, generate constructor with this message like this. So right now let's go to our implementation, user service implementation. Here where we're calling runtime exception, we want to throw our custom exception. Where else? Here also. And here when we find user by ID in our controller, let's also throw user not find exception, or I'll just come here and copy this, go to our controller and throw this exception. User with ID does not exist. So if you try to run this, let's test. So if you try to call this user, we will get a 500 exception. Let's test get this user. I want to test if this user, let's put something that is not existing in our database and call this. Okay, here we got 404. Why did we get 404? It's because we annotated with, if you can check here, we annotated with our response, we annotated with not found exception, so that's why we get 404. So but we want to have our custom messages, so we don't want this body. We want to have our custom body whereby we have our response call, we have our error code, and the date timestamp is okay, and the message that we throw here, user with ID, does not exist. So I'll show you how to implement this. So let's go to our exception now. And on our exception, we want to create a new exception handler, and I'll call it customized response entity exception handler. So on this exception, customized, okay, it's a wrong spelling. Let me refactor. You can do this. Refactor, customized. It's supposed to be set. Customized response entity exception here, like this. So for Spring to be able to have those global exceptions, there's this annotation that we're supposed to add called add controller advice. So let's add controller. Controller advice. The purpose of this annotation is to define global exception handling and centralized exception handling logic for the controllers in your application. It allows you to handle exceptions in a unified and consistent manner throughout your application. So by doing this, let's now add a REST controller. Then let's add this SLF4J from Lombok library to log our exception. We use this for logging. So now we can create our method that will handle the not found exception with the status code, with the error code, the message as a response body. So here we put public final response entity. So here it expects an object. For now, put a question mark here. So the mail is to handle not found exceptions. Then here we pass the not found our custom exception. And the web request. For now we are not using this, but just add this one. So here we want to return our response with the time, the response message, and error code. So let's create a record in our DTO and call it exception response record. a new record. So let's call it exception response record, and here let's change this to record, and the record must have this brackets. So in this record, what do you want to add in this record? We want to have a local date time, the time when the exception was thrown, and I can call it time, and also message, and also an error, string error code. That's all from here. Then here we want to add this response. That's the response that we want to add. So before we return we want to first log our exception. So we just do log dot error, in the name of the method I can say handle, just for handle like this, and just say exception. But we want to create our exception response record, new object that we are going to return here. Then we say local date time. Now in the message, it's exception dot get message, and here we want to add in our error code. So then we return a new response entity with an exception record and HTTP status not found. For this, we want to return not found because we know the record does not exist. But for error record, let's create our interface for handling errors. So this interface, we can call it, select interface here and call it error code. Everything like fields in interface are always public final, and I call it string cd not found. So this is the error code that we are going to send to our backend. Cd not found. _1. So we can have, and here I can say _1. So we can have cd means error code, the code not found _1. So this means if it's not found _1, it means its user does not exist. So we can have 2 here, meaning something different. User does not exist. So here we come back to our controller advice. Then we add our error code, we import our error code. So you can see this method so far is not working, and for this method to work, if we rerun again, we will not get our response code. We will not get our response with these three values, 1, 2, 3. So let's test again. It's not working, and we are expecting three values here. For this to work, we are supposed to add an annotation again here called exception handler. For this method to work, exception handler, and this we name the name of our exception. So the name of our exception here is this one. So let's test again now to see if it's now working. You can see this is the response that we got after we implemented our global exception handling, and this is the response code and the message. This user, we sent this user which does not exist, and the time when the exception was thrown. And here you can also, I think if the value exists, I think it's 9. So this one does not exist again. So we'll get this exception, and we on our logs we are going to see the logs here. This is our log, user with ID, you see not found, and it was thrown here, and it is handled in our customized response edit exception handler, which is this one. So this is the way how to handle global exception in Spring Framework. You must know that your class must have a controller advice, and your method must have an exception handler and the name of the exception, and you create your custom exceptions, and you return the response code based on the response code that you want. Maybe not found, if it does not exist, you can throw a 400 for a bad request, etc. etc. In this tutorial I'm going to show you how we can integrate with the Swagger on our Spring Boot application, so that next time we don't use a Postman. From now on, let's get started. So what is a Swagger? Swagger is an open source set of rules, specifications, and tools for developing RESTful APIs. So RESTful APIs are those that I showed you on the first tutorial when we created the get, post, put, delete methods. Those are the REST APIs. So with this Swagger, I'm going to show you how we can hit those endpoints using this API. So it provides framework for developers to create interactive API documentation. The documentation generated by Swagger is both machine readable and human readable. Swagger helps in describing and documenting the different endpoints, parameters, responses, and other details of an API. Developer can use Swagger to build APIs that are easier to understand and used by other developers. It simplifies the process of documenting and sharing API information, making it accessible to both humans and machines. The Swagger framework enables developers to design and develop APIs that conform to industry standards and best practices. By using Swagger, developers can ensure consistent and accurate documentation of their APIs, making it easier for others to integrate with and consume their services. So the integration that we are going to do with Spring, it's quite easy. We are going to add this dependency: Spring Doc, Open API Starter, Web MVC UI. We are going to use version 2.00 M4, and we are going to add the following configuration on our Spring Boot application: scan base packages, com.code with Bisky package, and this one is for Swagger org Spring Doc. And to accessing this endpoint, you just enter your your domain. So here we are on localhost, and your port /swagger UI.html. That's all. So we have these few operations, which we have the operations where we just summarize and add a description of what the method, like the API, does. And we have API responses, which is a list of API response, whereby each response we specify this API will return the following error codes, response codes, either 201, 400, 500, 401, 403, so that other developer can know which error code response codes to handle on their front end applications. So let's get started. So here we are now adding our dependents, and you can come here and sync, or you can right click here and go to Maven and reload your project. It will download the dependents. After doing this, we were told that you are supposed to add the package here. We are going to add a configuration here. So these are scan packages. So it's going to be an array because we want to add two packages here. One for Spring, one for our project, and the other one for our for Swagger. So for our project, it's com dot oro. If you don't know, you just copy this one like this. Then you put dot star to mean everything. This one is for the documentation. You can see for Spring MVC. So it will auto configure all these classes. Then after doing this, let's try to run our project. On this, we're told to access our endpoint, you have to use this URL. Let's copy the URL and paste it here and see if you are able to access. You can see we are now able to access our URL, and this is our documentation. So we are no longer using the Postman. From now on, we are now using this Swagger documentation. So let's try to add some few operations. Let's add for the create of users. You can see this create of user. We want to describe this documentation with the list of error codes with the response code that we have. So based on our documentation, let's go to the user controller. Let's go to the create. Where's the create? This is the create. So here we can copy and paste here. So you see the operation of this endpoint create user. It's like create a new user, the REST endpoint that creates a new user, and you're going to have the following response codes, either 200, 400, and 500. So let's rerun again and see. And you can reload here. You can see here, this is the summary, creates a new user, REST endpoint to create a new user, and with all the response code that you are going to have, server error, bad request, based on what we add here. So that's all, guys. This was a tutorial for Swagger integration with Spring Boot.
it's quite easy adding the following those dependencies, and also adding these packages, the Spring one, the Swagger UI, and your project dependent. Just copy it here. That's all, and add .star to include others like controllers, repositories. So thank you guys for seeing this video. I hope you like it. Don't forget to like, share, and subscribe if you're new to this channel. Click the notification bell so that you'll be notified whenever we upload a new video. Salut coders.